Section 5.3, we're going to talk about the angle-side-angle congruence postulate and the angle-angle-side congruence theorem. So these are the second two postulate and theorems that we're going to look at to show that two triangles are congruent. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So similar to section 5.2, where we looked at the side angle side congruence postulate, the angle had to be the included angle. Same thing here, the side has to be the included side between these two angles. So let me show you a picture. Here we have angle, included side, angle. So this is the side between these two angles. So here's a non-example. If we had, let's say, these bottom two angles congruent to each other, a non-included side would be here. So that is not the side that's between these two angles. That's a non-included side. So that would not be angle, side, angle. But here we have angle, included side, angle, angle, included side, angle. Again, just another example, we have angle A, angle C, and the included side between angle A and C is side AC, which makes sense. Side AC is between angle A and angle C. So for our proofs, we're always going to start with the two givens, or whatever, how many ever givens. So this is a given, this is a given, and I actually have both of those marked in our picture. So here we can see angle SRT is congruent to angle QRT, and angle STR is congruent to angle QRT. Second step, do we have reflexive property or vertical angles? In this example, we have reflexive property because we have this side that belongs to the top triangle and to the bottom triangle, and it's the same side, so of course it is congruent to itself. So segment RT is congruent to segment RT by the reflexive property. So we had two givens. We came up with another piece of information. So if you look at your picture, we have in this top triangle, we have angle, side, angle, and this is the included side between the two angles. And then down here we have angle, side, angle. So by the angle, side, angle congruency postulate, we can prove that triangle RST is congruent to triangle TQR. The important part here is that the side is the included side between the two angles. Next congruence theorem is the angle-angle side congruence theorem, and notice that the side is not included between these two angles now. So if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So here is an example, and I gave this as a non-example for the last congruence postulate. So we have angle, angle, side. This is one of the harder ones to recognize. So this would be the included side. This is the non-included side. Now another example of angle, angle, side could look like this. Angle, angle, and we could have this side. Right, angle, angle, and this side. So it's just the same as the picture below, it's just the other non-included side. So angle, angle, side, angle, angle, side. So again, let's start with our givens. Copy down your givens. And these are both marked in the picture for us. As you can see, we have angle K congruent to angle M, and then we have side KJ congruent to side MN. So step number 2, do we have reflexive property or vertical angles? In this case, we don't have any sides that are overlapping or shared between the two triangles, so, but we actually do have vertical angles here. So you can see vertical angles are directly across from each other, and I'm going to use 2 tick marks since angle K and angle M already have 1 tick mark. Now you cannot call this angle L because there are 4 angle L's here. So we need 3 letters to name this angle. So we'll name it angle KLJ. And then the best way to write the angle across from it is to use your congruence statement, and this is going to help you later in chapter 5. So right now it doesn't really matter. We could name it angle MLN or angle NLM, but it will make a difference later in the chapter, so let's just get in the habit of making sure that our corresponding parts match up. So if you look at your congruence statement, K is second, L is third, and J is first. So KLJ matches up with angle MLN. So I used my congruent statement to help me write the congruent angles, and these are congruent because they are vertical angles. So if you look at your picture, K has 1 tick mark, L has 2, and J has none. And if you look at the right triangle, M has 1 tick mark, L has 2, and N has none. So you can see that those are corresponding parts that match up. So now we have angle, angle, side, and that's the non-included side. Okay, that would be the included side, but the side that we have is not included. So angle, angle, side congruency theorem is what proves that my 2 triangles are congruent. Triangle JKL is congruent to triangle NML. Again, copy down your givens. And these are sort of already marked for us in the picture. So this is a given. This is a given. So angle A is marked congruent to angle D with 1 tick mark. And the next piece of information is that segment BC is perpendicular to segment AD. So they have one 90-degree angle marked in the picture. But if BC here is perpendicular to segment AD, then not only is this a right angle, but this is also a right angle, right? Because that's what perpendicular means. It means that it forms a 90-degree angle. So because we know that, we actually know that angle ACB is congruent to angle DCB. So we can say angle ACB is congruent to angle, and then if you just check your congruency postulate, just make sure you're right, ACB is congruent to angle DCB. And the reason we knew that is because of the definition of perpendicular from our second given. And if you want, you can abbreviate perpendicular with the perpendicular symbol, or you can just write the word perpendicular. So we actually gather that information from one of our givens. Now let's check, do we have reflexive property or vertical angles? Well, we do have a shared side between the left triangle and the right triangle, and that is side BC. So we know that BC is congruent to itself because it's the same side, and that is the reflexive property. So segment BC is congruent to BC by the reflexive property. And now we have 3 pieces of information. So let's see if it's any of our 4 congruency postulates. We have angle, angle, side. Okay. The included side would be here, but that's not what we have. We have a non-included side. Therefore, we know that is the angle, angle, side congruency theorem that proves my triangles BAC and BCD are congruent. Now, the order does matter. You may be wondering, so I'm going to come back over here. You may be wondering why you can't go the other way. How did I know to go from the one marked angle to the 90 to the side instead of saying angle, side, angle, right? How did I know not to go around that way? Because when you're going, you're totally skipping over this information up here, right? We don't know anything about these angles. You can't just skip over parts like that. So we're going from angle, angle to the side, but if you were to go angle, side, angle, you're totally skipping over information that you don't know. So that's how we know it's angle, angle, side. And this is probably one of the most difficult concepts to understand within writing proofs. And we have one more proof. So again, copy down your givens. I'll have to write these. So segment PR is congruent to segment SR, and that is already marked in our picture with one tick mark. And that's all that's marked in our picture. So our next given, we're going to have to figure out what we know. So R is the midpoint of segment QT. I'm going to highlight segment QT in the picture, and I highly recommend this strategy. Otherwise, you might get the wrong segments. So segment QT, R is the midpoint. Midpoint means middle, which means that it cuts the segment in two equal halves. So this first half, QR, is congruent to the second half, RT. And that is by definition of midpoint. That's how we know that one half of that segment is congruent to the other half. So segment QR is congruent to segment RT, and we knew that by definition of midpoint. So right now we have two pieces of information. Step number 2 in our proofs, do we have reflexive or vertical angles? We don't have any overlapping sides that are shared between the two triangles, but we do have vertical angles that are across from each other, and we do know that vertical angles are congruent. Do not name this angle R, because there are 4 angle R's, and if you say angle R, you're going to have no idea which angle you're talking about. So we need 3 letters. We can either name the left one angle QRT or QRP, or angle PRQ. Does not matter. We can name it QRP. Angle QRP is congruent, and then again I suggest using the congruent statement. So QRP is second, third, first, so we'll go angle TRS. And this will matter more later in the chapter, that you actually make sure the corresponding parts are matching up. So we knew this because they are vertical angles. So if you look at your picture, angle QRT goes from the green side to the red side. And on your right triangle, TRS goes from green side to red side. So that's why our congruent statement helps us. So now we have 3 pieces of information. We have side, angle, side. And that is the included angle between these 2 sides. And then side, angle, side. So by the side, angle, side congruency postulate, we can say that triangle PQR is congruent to triangle STR.